if I don't have everything perfectly set up and ready to go,
Yeah.
as comfortable and as much as I. Ooh.
There's another one.
It's just tumbling around.
Yeah, little swimming colonial algae.
Do they always form structures of like a
All different shapes.
Is it like different volumetric, or is it generally like on a 2D plane?
They can be different. Yeah. It's not always 2D like this.
What are
air bubbles?
Oh, okay.
Yeah. It's kind of cool though. Now I'm recording this, so it'll also record our voices.
Oh, that's so cool.
This is kind of a cool diatom.
So the diatom is what you said. It has glass structure around it.
Yeah. Ooh, there's an amoeba. These take a while to move.
Amoeba. Is that the little?
This one.
Oh.
You've heard of amoebas?
Yes.
Yeah. Well, I followed one today for 1.5 hours. They take a really long time to do anything, but you have to record it and then speed it up. But it's slowly doing something.
So is that like
pseudopods? It's like extensions of the cell membrane. That's how it moves around. And this one will slowly move too, but it's gonna take a while, so I might get bored with it. But you can see all the stuff inside of it. Yeah, I love amoebas, but you really have to be like really, really patient and just record them for a long time. But yeah, let's keep moving. So a bunch of diatoms here, and these are diatoms from the Charles River. They will also move. Like this diatom is moving. There's another amoeba. Oh, I'm liking this culture. Maybe I'll send Cricket this culture. They actually move by secreting a mucus and sliding along it.
The diatoms?
Yeah. So, but now we can try to do a time lapse actually, if there's enough of them moving. Yeah, this is kind of boring. But
what is this little area there?
That's an algae.
Oh.
Yeah.
Is it moving or is the diatom?
I think it's stuck to the diatom. Oh, holy crap! There's 2 amoebas. Wow. This culture really took off.
Is that another one?
Yep. Yep. Wow, this is like an amoeba culture. That's cool. I think here comes our friend, the triangular swimming algae. I love it. Moving along. So the time lapse, it's not a very active one. If you wait long enough, this guy's moving. You can actually kind of create something. Depends how active it is. It's not very active. Wow, there's so many amoebas. That's so exciting.
Oh, so also as you're moving it, that's.
Yeah. So.
Is that it?
This I think is a cyanobacteria, but I could be wrong. The cyanobacteria also move. I don't know how they move though. But yeah, perhaps in a diatom. Rotifer.
So are rotifers mainly what cricket, or a lot of what like cricket?
Yeah, she likes rotifers a lot.
What are the brainless things that still learn? The other, like one of the main things that she studies.
Stentor?
Yeah, stentors.
Yeah, I don't know if we'll find those, but we will find other ciliates, which are relatives of stentor. Rotifers could be really cool in time lapse if you get one feeding, because they make these feeding currents, and it like swirls you get these like currents. It's really cool, but I don't think these guys are feeding, but they're not doing the currents. Yeah, so, but there's like a zillion types of rotifers.
When you say like when they're feeding and swirling, is it the kind of like the thing where like their insides almost swirl?
That too. But so many amoebas. I'm so excited. This one has a weird pseudopod.
I wasn't looking at like her
What is all of this stuff? What is all of this like in the amoeba?
I mean, like food and like vacuoles and digestion sacs and yeah. When you first put them on the slide, they are star-shaped because they're kind of like getting their bearings. But oh my God, there's so many amoebas! It's so exciting. A little higher magnification. There's one of those little algae guys. Little flagellate. Oh my God. So many amoebas. I didn't even like concentrate this. But I don't normally find this many amoebas. This is very odd. But this microscope also does something called differential interference contrast.
Oh, is that where it only highlights the things that are moving?
It's more just a different type of light. So this is called phase contrast, and it adds contrast to the membranes. Normally this would just be like kind of boring, this, but the phase kind of makes it cool. And then if I can remember how to do this, I think it's K2 and C, is it? So it uses polarizers, 40 and A. There we go.
Ooh.
And you can actually, this is a little bit thick, so it's kind of, you can change the color with the polarizer. But let me go somewhere that's thinner. But no, it's okay. It's a little fuzzy, but it kind of like is like trying to find a less fuzzy spot. But like it makes stuff kind of looks like a relief. Like there's like side lighting from it.
Yeah.
Ooh, amoeba.
So this almost like gives a little bit. I forgot the technical name of it, but they're like certain like microscope. I don't know if that's the right term, but like things where like it'll push down and it only reads like it'll give you like a topographical.
Yeah, like
what this is going at.
Yeah, so it does like sectioning, optical sectioning. Yeah, so diatoms have this really intricate shell with like all these little pores in it, and these have them too, but like you'd have to see it with an electron microscope to see the little pores. They're really quite like, I don't know how they make these. Which is actually quite boring, but I wish I could show you some marine critters. Let's go back over here. Ah, shit. Okay. So it doesn't look quite as good with the low mag, but I can change the color with the polarizer. I might want to look. Ooh, Heliozoa.
Oh my God.
It's a cool one. So there's actually an amoeba inside of there. This is a rigid structure, and these are its little actinopods, and it's like bubbling out a little. Yeah, these guys are cool. They're really cool. But it's called Heliozoa, like the sun.
Oh, what?
Whoa! It just like that's cool.
What?
I don't know what I was doing. Maybe it's sick. Or like eating.
Oh, little buddy, it's gonna be okay.
Yeah.
That's a hard structure that
this is the hard part, and these are soft. and I believe it like catches bacteria on those things and like pulls them in and eats them. So it's related to amoebas, but yeah. He's got, looks like he has some endosymbiotic algae, so a lot of the ciliates and stuff that cricket studies, they can eat algae and then photosynthesize. Like if you could eat plants and get energy from the sun, they're an animal, but they eat a plant and then they can like use that chemistry and get energy from it. And it's like, I want to be able to do that, man.
Yeah.
So it looks like maybe he's catching some bacteria. The little, sometimes you can see the bacteria. They're little like dots. Like these are bacteria. And bacteria are considered plankton too. Ooh, that's kind of cool. I forget what those are called. Yeah, I don't think we're going to get very good time lapse out of this. But unless we do amoebas. So this is at 200 times magnification. Doing something. Yeah, I watched an amoeba for 2 hours today, so I'm kind of bored of them. Yeah, well. And then that slice junk. Just a quick scan. We can also go to fluorescence. Another amoeba. This is not the best sample for time lapse because there's just not. Yeah. I think that's like a fungus. We do kind of, the cultures do kind of get fungus sometimes. Microplastic from the Charles.
Wait, is that like that big thing?
Yeah, I find microplastics all the time. Yeah, so that's fun. There is some little stuff. Oh my god, there's another heliozoa. Let's zoom in on this guy. They're cool. I wonder if I can do time lapse. I think he's moving too much. But I do like heliozoa.
I mean, it looks like it's its own little sun just radiating out stuff.
It is, yeah. And these are all like, these are kind of like an amoeba has, but just a little bit stiffer. And then actinopods, they're called. And they catch bacteria, and they eat it.
Ooh, that.
Which one?
Yeah, that.
There we go. Ooh, oh, diatom. So many different types of diatoms.
I feel like whenever I experience stuff like in the very micro,
Yeah.
it feels so similar to the macro.
Yeah.
Like, it's just.
That's a flagellate. I could record this amoeba for a while and do a time lapse, but I might be too. Oh, this one's kind of cool.
Nice.
Going in a spiral. Kind of just gotta be patient with the time lapse, depending on activity level. But yeah, this is also a plant because it's green, but it's swimming, right? This amoeba is nice. You can see this amoeba has eaten a plant. It's got green in its belly. This guy's going kind of slow. I think that's its flagella. Like
Did it just disconnect?
I don't know. Maybe that's why it was going so slow. Yeah, I don't know. So yeah, maybe it just died. I think it just died. Well, let's see if maybe it'll start up again. This amoeba is nice though.
This is crazy. This is so fun.
I have endless fun with this. This is a boring sample too. Like seriously, like go to the Charles, like an actual living system, and you'll just find crazy shit.
It's just, what is that? Yeah.
But I think it did die. Oh wait, I think I see its flagella. No, maybe it did die.
Damn.
I see things die a lot.
That's so. It's such a interesting. Like it's so small. It's about like it's present and now it's not.
You should see a rotifer die because I have this whole thing. Senem actually did sound. I'll send it to you. It's called Death Reel, and it's just a compilation of stuff dying, but like more animal-like things than just like a ball. And you really feel for them, like a tardigrade as the slide dries and it gets crushed.
Really?
And it like really makes me sad. But Senem did sound for it with using like my internal body sounds. And it's kind of, yeah. This is okay. You can see the amoeba and all its pseudopods. So I just like take a photo basically.
It's so fun watching like its insides just slowly just tendriling
Like just
out.
imagine like if you could be an amoeba and like that's how you interface with the world. Like it's like our white blood cells. It uses like actin and microtubules to polymerize and repolymerize and depolymerize and push the cell membrane, like how our cells move, but they move kind of faster, but similar to white blood cells. Like on top of a diatom now, what am I going to eat it? It's a little big for it.
I feel like watching how all the tendrils are just constantly like out seeking. I feel like this is almost like a visualization of like a simplification of like how my spirit moves and how my spirit explores different things. Where it's like 15 different directions. Okay, let's go in this direction.
Yeah. Those are called pseudopods. Some little guys. Let me make another slide. That one I haven't looked at in a long time. I'll have a look on it. I'm curious to see if anything is alive in there. There may be nothing alive in there, but I'm just curious. I might call it.
Mind if I shift these over just a little bit?
Yeah, go ahead. So see what is in this other one, originally from the Charles. This was more of a winter culture, but then I added algal growth medium, so that's why there's stuff in it now. It's sat, I don't really know now, it's sat in my car frozen yellow light with like food. That was amoebas and stuff. Originally from the Charles again. And I have this other culture originally from the Charles. Okay, I'm going to concentrate a bit. There. Concentrated. But I'm going to try. What was that for me?
Oh, and is there like a little filter there?
Yeah. 0.4 micron filter.
Is that small enough where it doesn't like let amoebas and things like that?
Yeah. This cloth though, do it hard at the end. Just kind of reducing that volume. Still want to do some more. It's going to take a minute. Yeah, of course. Always. Not everyone is like into it.
This is so boring. This isn't even. You're right. It sucks. This is really cool.
I have so much fun with it.
Yeah.
If this is a boring sample, you should see a cool.
I also like. I love the escalation that like within 2-3 days of like really starting to like see cricket stuff.
Yeah.
Starting to interact with that.
Yeah.
And then just like, oh, you're in Boston. You should go see such and such.
Yeah,
and it's like, oh, yeah. Who am I to resist the whims of the spirit?
Yeah, we are kindred spirits. I'm really glad I met her.
The first time that I met her,
I've never met her in person or like even Zoom with her, we just chat. Right.
but like she kind of said what she did. And it was one of those things where it was just kind of like a big question mark in my brain. I was like, I hear words that you're saying, but what?
Yeah.
So what is your favorite thing within your samples? Like,
I mean, I do like amoebas, but favorite, I like the polychaete larvae, but they're in purpose. They're like benthic bristle worms. They live on the bottom.
okay.
I mean, but they're planktonic because they're in the water column when they're young and like swimming around, and then they distribute themselves and then like burrow into the seafloor and live there. A lot of insects do that. Like barnacles. Barnacle larvae, you can see them swim around and then they like settle down.
Like they get a house, they get a
Yeah.
like that.
Yeah. Almost good. Okay. So I concentrated all that water to this.
Oh wow, all of this. Okay.
So what's in there? little person. And you can also look at it with fluorescence. So it's a different type of light. That was cool.
Does some of the stuff in there like react differently to the fluorescence?
Yeah, different colors. Exciting. A lot of it is just junk, but our amoeba's still going. Oh my god, is it gonna eat something?
What?
Oh my god, oh my god. Okay, we're not gonna change the slide yet. I think it's gonna eat this. Oh my god.
We're looking at the thing in the center right.
Yeah, the thing that died. Oh my god. It's so rare to actually see them eat something.
Oh wait, it's actively eating it right now.
Yeah.
Oh.
Oh my god. It's exciting. And it's got like a diatom inside of itself. It's like eating a lot.
Is the diatom what's in the back right?
Yeah. Okay, we have to watch this for longer. Because I'm gonna like speed this up. It is recording, right? Yeah, it's recording.
I love that you have it set to where like records the audio.
Yeah. Some people don't like that because I don't know, but I think it just ate that. So it'll like, unless it's just going around it, but it'll like digest it, like secretes digestive enzymes.
Can you watch it long enough to just see it break down?
No, that takes a long time. But I don't actually see them eat very often, so this is exciting.
That's crazy. Watching the life cycle of you just being able to, swimming around, having a good time, dead, now eating.
Yeah. Oh, it's still alive even. Did you see it twitch?
Is that the...
It's twitching. But it's like being eaten.
Have you ever read Flatland?
You know, when I was like younger.
I
Yeah.
feel like this is like a...
It is Flatland, yeah. I think it did eat it. So it'll form like a food vacuole and like digest it. I think it's trying to eat that diatom too. It's just going over it. Hungry little guy. Awesome. Cool, I'm gonna speed up that video. Ooh, too late. I'm gonna speed it up and then we'll be able to see it like still alive. It's getting digested. Like imagine eating like that too, like oozing your mouth around stuff.